Okay. Um, so normally in an honors pre-calc class, I don't spend any time on factoring, obviously, okay? That should be just like you should be able to do it in your sleep, but I find that we are not that way necessarily because of the order in which we do our courses here, where we have Algebra 2. You had that in the 9th grade. A lot of people have Algebra 2 maybe in the 10th or 11th grade before they have honors pre-calc. And so I'm just going to give you how I factor. And I think and I've seen everything. I mean, I've seen the charts, the crosses, the thought processes that you do. But if you wonder, I remember sitting looking at my pre-cal and calculus, not calculus, but my pre-cal, or really my Algebra 2 teacher made us really good at factoring. Nobody ever talked to me about it again. We were just expected to be able to do it. But I remember watching Miss Hoshk at first thinking, well, she has insider information. She's going to she's so much better at it than I am. And we all got as fast as her. I think we all could factor as fast as she could. And there's no trick. Trial and error is the best thing in the world with the brains that you have. I wouldn't go off, if you go off to the side and use some trick and you do all this B, C, A, C, chart cross stuff and listing them. I mean, I think you're going to look up and people are going to be 2 problems down the road, okay? And by the way, we only factor when it's easy for us to factor. If smart people like you can't factor it, it probably can't be factored. It's going to be a rare event, if ever, that I use a quadratic formula, by the way, okay? Not really care about the quadratic formula. I don't want answers like 5 plus or minus square root of 2 over 7 anyway. I can't do anything with that. I need decimals. And also, many things are not quadratic. So the quadratic formula, sorry to say, is not all that we maybe made it out to be, okay? It only solves quadratics. So if I have something else, what in the world am I going to do, okay? So I'm going to strongly suggest when I'm showing you, this is what I do when I'm factoring. If I can't factor it really fast, then I usually just go straight to my calculator and find the zeros that way, and we'll talk about that another day, okay? So anyway, we'll talk a little bit about factoring, then we're going to go on. All right, I'm going to do 7x squared minus 31x minus 20. Starting off with a bang, like that's as hard as it can get if you're trying to factor a quadratic. I wouldn't even take notes right now. Please just watch me, okay? The very first thing you want to do is see if there's anything in common, a number or an x. Kate Unrath, ask her. The first rule of factoring is factor out what's in common, and people forget it like crazy. We say it in my pre-cal class almost every day, okay? We may say it in here just as we greet each other and you're walking in the door. Factor out what's in common, okay? Even if you don't, kind of think sillily to yourself like, I don't know if sillily is a word, but anyway, there used to be an ice cream place called Sill Lily. Anyway, please take out what's in common first to make your life easier, okay? I don't see anything in common. Now, one thing I don't want to do is factor if it won't factor. And so I do use the part of the quadratic formula, the discriminant, quite often, okay? I don't want to sit around and factor if it won't factor. However, I really don't want to do b squared minus 4ac right now either with 31 squared. I don't know what it is. I could find it really fast. But for argument's sake, let's do it. I probably wouldn't here. I'd probably just start factoring. But how frustrating it is to spend some time on one like this trying to factor it if it's prime, okay? I also want to say this really loud. I feel like I should shout this. Just because it doesn't factor does not mean it doesn't have zeros. That may be shocking to you. You may have thought that's why you were factoring. It's just not going to have nice, sweet zeros. It doesn't mean there's no zeros. Are y'all okay with that? All right? Quadratics are going to always have zeros unless they're completely above or below the axis. Okay? So all you're doing when you're factoring is seeing, you're just kind of doing a front runner to see, is it numbers like 1/2 or 3 or something like that. Okay? All right, so I'm going to do 31 squared. Why am I ignoring the negative? It's because I'm squaring it, so I don't care if it's positive or negative. 961, I hope. Minus 4 A is 7 and C is negative 20. Ooh. So I get well, so now I still don't have a clue. What's the square root of 1521, Grace? Provided that I did I'm really bad at, okay, thanks. What I was going to say, I'm really bad at like elementary algebra. I mean, arithmetic. I'm not very good at adding and subtracting. Anyway, I just don't have the patience for it. All right, this was probably not a great one for me to start with, but there's many times, girls, that you'll have a calculator at your disposal, but you still have to go back and factor the thing. You might have a calculator right there, but you still, please don't do anything else, just listen, okay? Unless I need to pause while you catch up. Y'all okay? Yeah. Okay. Because I really want to hear all this. There's lots of times I have a calculator beside me, but I still want to factor so I can cancel and reduce or solve a problem. And so I can do a quick check on b squared minus 4ac. Isn't that under the square root and the big old quadratic formula? That's called the discriminant, okay? If I had done b squared minus 4ac and gotten a negative, I would stop and go, this has no solution. It's not even touching the axis. Can you square root a negative in the real numbers? Okay? If I had gotten a positive like 17, I would keep on going. I'm sorry. If I get a positive like 17, I don't know the square root of 17. That means I'm not going to be able to factor it. I'm going to have to use my calculator to find the answers. Okay? Factoring is only checking possible. You know it's got an answer. It's just not one you're going to come up with. It's pointless for you to try to factor if you don't get a perfect square. If you get a perfect square, she square rooted that and I got 39. That means in the quadratic formula, I would have something like 31 plus or minus 39 over 4a, whatever that would be, over 20a. Do y'all see what I mean? But if you have something like 5 plus or minus the square root of 11 over 8, you are not going to come up with that with factoring. That means you're wasting your time. So the strongest part of the quadratic formula you might want to try is b squared minus 4ac. And a lot of times it's a small number like 49. And you know, oh, this will factor. I better keep going, okay? If I get something like 47, I'm not going to sit around and keep factoring. I'm going to go on to something else. But there's other ways to look for that answer. Factoring is a quick check to see if you could have done it before somebody opens their calculator, quite honestly, okay? If this hadn't factored, I'll teach you later to type out your y equals, and then you can push buttons like calc 0, and you can find those decimal values. Okay, but some of you may know how to do that already. But if I can factor it, I can probably do it faster than you can open your calculator, or you also, not just me. You know, if it'll factor, we probably have already found the zeros by the time you typed it in your calculator, let it graph, and went to calc 0. If you've ever done it, it's a little bit time consuming. You have to wait for it to give you one answer, then you've got to find the other answer, and we're all sitting around, maybe we've already factored it and we moved on. So factoring is important, but it's only important if it's something you can factor fast. Okay? Big deal. That's why I was so adamant at the beginning that you listened to me. B squared minus 4ac is very powerful. It lets you know if you have to sit around and try to factor it. If not, you'll do one of the other techniques. There's other ways to find zeros. That's what I wanted you to hear really loudly from me, okay? Factoring is just a way to find the nice sweet zeros, like 3/5 and 7. All right, so this is what I would do. I always look and see if it has anything in common. It doesn't. And then I'll draw 2 parentheses. I never work with a pencil because my hand hurted. My hand used to hurt, and I took so many math courses in college, and I had to write in pencil for most of them. And I don't know why writing in pencil made my wrist hurt. So I just have to press harder. So I haven't written in pencil since college. I never even know where a pencil is. So I do this with a pen, and I'll just scratch out or write over like I'm doing right now, okay? I factor the front, then I factor the back, and then I worry about the middle. Please don't worry about the middle until you've got your other 2 numbers set in stone, okay? Or not set in stone, set. You may not have it set in stone. Please look at the backs and the first, and then worry about the middle, okay? And if you had me in Algebra 2, which not many, a few of you did, I do it with these little smiles. I'll even use yellow. I like to smile. Smiling is my favorite if you've ever seen Elf. That's a quote from Elf. But smiling is my favorite. Do y'all remember that scene? Okay. So anyway, Those are awesome. That'll check your middle number. I love those smiles, okay? Now, the reason that works is this is first, this is outside, this is inside, and then this is last. That's where the FOIL comes from. So when you're doing these two smiles, you're checking the middle number, all right? When you put something here, you're creating the first 7x squared. When you put something here, you're creating the last 20, but then don't you need to know how it all interacts to give you a 31 in the middle, okay? All right, so this is what I would strongly suggest. This is what I do, all right, after teaching 9,000 years of factoring, okay? I factor the front. Right now, thank goodness I don't really have many choices, just 7, and you don't have to write the 1, 7x and 1x. Factors of 20, just trial and error. You get where you can kind of look ahead. I'm going to try 4 and 5. I accidentally just got it right, okay? Because that gives me 35, and this gives me 4. Can I get a 31 out of that? Okay? And so the signs right here, that means that one of them's got to be negative and one of them's got to be positive. All right, so I check my sign now. One of them has to be negative and one of them has to be positive, and I know the 35 has to be negative to make this negative. And then I'm done and set them equal to 0 and find my answer, okay? By the way, please don't ever do this. Some people in Miss OD's class were doing something like this. They got down to a calculus problem like that, and then they factored and set both factors equal to 6. That never, ever works. You're guaranteed to miss the problem, okay? Some people think, oh, well, you taught me to factor and set it equal to the other side. No, what was the other side always? 0. Okay, so if I have a number times a number equals 0, then either this one is 0 or either that one is 0, right? This is huge too, because people in AP Calculus are still missing this, so listen up, okay? If I can take care of it now, I won't see it next year. Do y'all see why it's called the zero product property? I didn't probably even really get that when I was in Algebra 2. I probably made that same mistake before. I thought I could factor probably for a moment or two and just set it equal to whatever the number is on the other side. If I have two factors, A and B, and it equals 6, there's all sorts of things A and B can be. But I tell you what, you're going to miss it. If you say, well, this one's 6, and this one's 6. You're going to miss the problem if A and B are both 6, okay? But neither one of them has to be 6, does it? Do you see why we get it equal to 0? If we get it equal to 0, one of them's got to be 0. So I always get it equal to 0, okay? All right, now, sorry, I didn't even want that one to work out that fast. Let me look at one more. All right, we'll do 2b squared plus, I want to do one that has more stuff in the front. Let's see. There should be more problems. It's 1 out of 4 pages. Why wouldn't it let me scroll? $30 38 squared, 87x, and 30. 30, 87, 30. All right. 30, 87, 30. Thanks. All right, these are T's. All right, you're just watching me, okay? You're going to have plenty of time to factor on your own. First of all, I'm going to see if there's anything in common. I don't think, 87, girls, is a multiple of 3. How did I know that? Added together and I get 15. So it's a multiple of 3. So, girls, my life's going to be a lot easier if I factor it first. If you don't do this at first, you'll have something that you still have to factor down some more and simplify at the end. So let's factor out a 3. And that gives me 10t squared minus 29t plus 10. Double check that you took out as much as you could, okay? So now I have some choices. For 10t squared, I'm going to factor the front, factor the back, then I'm going to worry about the middle, okay? By the way, let's see if this factors before I go on. Would somebody type this into their calculator? I'm doing b squared minus 4ac. 87 squared minus 4 times 30 times 30. See if we get a perfect square. 30,960. And then square root?
Well, like,
okay. Oh, you already factored it, Elena. Okay. So I might try 5 and 2, but I'm kind of curious with the 29 if I need 10s and 1s. But I think most of y'all would start with 5 and 2. Okay? And then 10, you can use 10 and 1 or 5 and 2. I'm going to intentionally mess it up, by the way, if you've already factored. A lot of people like the 5 and the 2. I'm going to do my smiles. That gives me 10 and 10. I didn't get 29, did I? Girls, listen. I didn't get 29. So I can quickly change these to 2 and 5. So I'm going to change this to a 2 and a 5. And then try my smiles again. That's a 4. And this is a 25. I can get a 29 out of it. If that didn't work, I can quickly change it to 10 and 1. However, you get so good at it to where you usually don't have to do that. You get to, if you do the trial and error, you'll get to where you can see ahead. And you can factor really fast. If you keep going off to the side and doing all these little charts and cutesy things, you're not going to get better at it. Okay? You really get to where you can see ahead. Now my signs have to be the same because it ends in a positive and they're both negative. And so there's my factors. All right? Okay, so now let's get started on what we're going to be doing. Let me find my sheets. I had them up here already. Now I've lost my notes. I had them all ready up here at the podium. Now I don't see them. Which is okay, but okay, here they are. They were in my chair. All right, now what we're going to do is this. We're going to solve some equations. Before we do this, let me give you like some of the harder stuff, which sounds really odd. Like, oh, before I do the easy stuff, let me just give you the hard stuff, okay? So listen up. Suppose I have 2 sine x plus 1 equals 0. Now you've got to solve for trig functions, okay? Treat it just like it said 2t plus 1 equals 0. What would you do first to solve this equation? What would you do here? Subtract 1. So I have 2 sine x equals negative 1. Then what would you do? Divide by 2. And that's why I make you memorize, because now, and that's why calculators are a moot point here as far as my class and someone else's class. And y'all know how strong you are without your calculator, but I also want to make you strong with your calculator. But girls, if my students are in a position now, they have to yank out their calculator, turn it on, type it in to figure this out. Do you see how you will be behind the rest of the world? You should recognize that. It's just like if I've squared to 25 and I've got to go to my calculator for that. I should be able to keep on moving. Plus, your calculator is going to make you miss it. Because what are you going to have to type in next? Inverse sine, aren't you? Of negative 1/2. And how many answers will it give you?
A lot.
How many answers will it give you?
Oh, it'll give you 1.
It'll give you 1. How many do you need? A lot. Okay. What's the first one that comes to mind? All right. Negative 30 is 1. All right. Let's talk about what you're thinking. Sine is, now look at what this says. Does my problem say inverse sine? It does not. You are on this function right now. Y'all see the difference? You might use inverse sine to help you, okay? We're going to do degrees just because they started me in degrees. Sine is negative here and here. So somebody went down and grabbed that reference angle. Can anybody name another one? 210. Any more?
150.
No, almost, but sine is positive right there. 330. And 330 and negative 30 are coterminal, but if you're thinking about the sine wave, they're different answers, aren't they? Here's a sine wave. You're looking at where sine is negative 1/2. This one is negative 30, or negative pi over 6. This one is 210. If I'd continued on out here, the one right next to it is the 330. Zaina, what about this one? I think negative 150 would work. If I go the other way? If I go this way with Zaina, wouldn't that be negative 150? Okay, it is 11:05. We have 20 minutes. Will I be finished with this problem in 20 minutes? I'll never be finished with this problem. Okay? Brianna, when's your birthday? August 16th.
You asked me this in another class.
I'm doing it on purpose. I thought it was you that I'd ask, okay? August 16th. I don't know how old Brianna is. I could sort of guess 16? 16. So I could like really fuss at her for not telling me every birthday. I'm like, I asked you when your birthday was, not your birth date. I want to know all your birthdays. We also don't know how many that we're all going to have, right? I'm going to have far less than you. But anyway, we don't know how many, it's kind of sad. We don't know how many. I was 21 when I started teaching high school, so it was about the same back then. But anyway, it's not anymore.
Did you teach seniors?
Yeah.
Because that's like barely an age gap.
Yeah.
That is really
Were y'all in here with that? Was anybody here when that woman came in the other day after school? Anyway, I taught her. Hopefully it's hard to tell which one of us is oldest. So let's keep moving. Okay, shh. Off the morbid subjects. Shh. So let's take something that also lands like Thanksgiving. I can't really say because it's on different dates. Same as like Easter, Memorial Day, and Labor Day and stuff like that. So we'll pick something like Christmas or St. Patrick's Day. So let's pick St. Patrick's Day. So I'm not stomping on anybody's religious persuasions. Okay. So I love Christmas. So March 17th. Shh. I feel like I'm having a y'all listen. March 17th. Okay. As long as we have practiced St. Patrick's Day up until we stop practicing St. Patrick's Day, we'll have that on our calendar March 17th, okay? It happens every year. So that's why Brianna can get away with August 16th, because I know that happens every year. I could mark it on my calendar, which would be hysterical if I tell her happy birthday every year.
What if you just have this like a...
I need a reminder, yeah. However, then when I'm not around anymore, I make her sad. She'll go, oh no. Okay. Anyway, away from the morbid, back for a minute. What happens if we are like a friend of mine? Her anniversary is February 29th. So even though this is fun discussion, think with me. It has a different. If your birthday or your anniversary or something is on February 29th, it has a different period, doesn't it?
Yeah.
The cycle or the period of most of our birthdays is every year. If your birthday was on February 29th, that happens every 4 years.
I love
okay?
that. I wish I was born then.
Then you could be really young. Okay, do y'all see what I mean? So that's what you're going to do for me here. What I'm going to do is I'm going to really name the first two that I think of. My two may not be your two, okay? But I'm going to grab the first two that I think of as I'm going around to 360. I'm going to grab the first two that I think of as I move around this. Okay? I hit negative 1/2 here and here. So it's like if Brianna had two birthdays. There's some people that celebrate their half birthday. If they have a birthday in the summer, they don't get to celebrate with their friends. So maybe, I don't know, really got half a year here, but if your birthday's June 6th, and then or July 6th, well, do you see you might celebrate half a year later. There's some things that happen twice during that year all the time. Like your parent would open the calendar for the next year and mark those 2 days. Turn the calendar and mark those 2 days, okay? Or if you have more than one child. I have 2 children, and so I don't have to mark the dates because I remember their birthday. But suppose I didn't.
My doctor's always had my own birthday.
Huh?
My doctor's always had my own birthday.
Oh, I've heard of that before.
Yeah, so I might be born on the 21st. You never know.
Oh.
I would like that better.
So anyway, did y'all see that I've got March 11th and June 4th. If I was going to mark their birthdays and was afraid I was going to forget them, I would put them on my calendar every year. I would get those 2, and then I would put them on my calendar for following years, okay? So I would find the first 2 times it happens, and I would list them. The first 2 I think of are going around in a positive direction. Sign is -1/2 here and here. And then I want to add a year to it. Well, not really a year. What's the period of this sine wave? I'm going to add 360. However, all that does, girls, is take me from these 2 to the next 2. Actually, what I have written on the board doesn't even include these 2, does it? It doesn't include these 2. It's like if I said August 16th plus 5, then we're talking about when she's 21, all right? So I've got to find a way to include those 2, and some people use different letters for this. I use a K. I think our book sometimes uses an N. I'm going to use a K, and I'm going to have to define what K is, where K is any integer. Okay? Name me some integers, Grace Hooper. Hopper, Hooper, I'll never remember that one. That astronaut's ruined my life. Okay, so, and there's Andrea, Billy, Boop, and George. Name me some integers. 2, 3,
5.
5,
7.
0, -8.
Yes. Yes.
Just checking.
I actually don't.
Integers are like how
They're
many
not
non-fraction.
fraction.
They're non-fraction numbers.
Yeah.
However, 4 is 4/1.
Yes.
Okay. So the integers are the ones that you would write on your x-axis. You go -5, -4, -1, 0, 1, 8, whatever. Okay. Those are your integers. They're not things like 2/3 and -5/8. So this includes everything, girls. I'm telling you, you could pick any integer. So I could start asking, Brianna, what was your 3rd birthday party like? What was your 8th birthday party like? What's this birthday? Your sweet 16. You know, what are you going to do for your 25th birthday? Whatever. Okay? Where K is any integer. So if I pick 0, then I've got these 2. If I pick 1, I'm looking 1 year later. If I pick -8, I've gone back, turned my calendar back 8 years. Okay? So please get out your calculators and do this with me. Put it in degrees, because we're in degree mode right now. Type this into your calculator in degrees.
7.
Sine of 210 plus 85 times 360, and tell me what you get.
So it's also.
Did you get -1/2?
Yes.
Okay. So I went 85 cycles out. Do y'all see what I did? I set the calendar over 85 years. But I'm doing it in 360, so I'm just going like this. Down, way down this. So do you see how it gives me every answer in the whole world? Some graphs don't have the same period that we'll have to deal with. With tangent, I would add 180, not 360. Okay?
So like 180 represents a year for it.
Yes, you've got to think what its period of time is. Like on February 29th would be every 4 years.
Because
So you always have to think of the period of the graph you're working on. Now let's make it a little bit easier. I did it difficult. Now let's knock it back down to this equation. Okay, so what I have right now is 4 tangent x plus 4 equals 0. And we're going to do this from negative 180 to 180. Pause. Don't work that, please. Listen to me. If you could read my writing and you work that problem, you would find a ratio that you know from your memo page or your unit circle. Okay? What though if I end up with tan x equals 1/3? That's why we just did everything we did about inverse functions, girls. I don't know tan x equals 1/3, but I know there is one. If I push inverse tan 1/3, which I'm going to have to do, all it's going to give me is a starter number. Does that make sense?
Yeah.
Because you've got to look at what your original question is. No one asked you arctan. If I ask you arctan, I only want one answer. But I'm on the tangent graph, and I'm after you arctan to get you started. Okay? All right, so did most of y'all get to this point, tan x equals negative 1?
Oh, it's a negative 1? Subtract 4. Oh, it's positive. I just didn't know it was positive.
Okay, are we okay?
Yeah.
Hang on, I've got some puzzled faces. 4 tan x equals negative 4. Divide by 4. You're doing algebra. Tan x equals negative 1. All right, now, many times they'll give you a domain, okay? Just a period of time to look in which there's just a set number of answers, okay? So if I go this way, look into negative 180, tangent's positive here and negative here. So one of my answers would be negative 45 degrees. If I go up to 180, tangent's positive here and negative here, so I would say 135. Are these two numbers between negative 180 and positive 180?
Yes.
All right, if I look at a graph of tangent, we usually did it in radians, but this is 90 degrees. This is negative 90 degrees. This is 180 degrees. This is negative 180 degrees. And did I draw that right? No. Tan of 180 is 0. So this is 180, and this is negative 180. That's right. All right, so if I look from negative 180 to positive 180 in this window, and I'm looking for it to be negative 1, how many answers should I have gotten? 1, 2. 1 kind of close to the axis, negative 45. 1 almost all the way to 180. Do you see how it makes? I always like to draw pictures, by the way. I feel like if you see it, you can understand it a little bit better. You don't have to do all of that, but I want you to see what's happening. Do y'all see how I got 2 answers and they make sense to me? Okay? All right, so let me let you try one after I answer Elena.
Are there more than 2 answers, or are there only 2 for this one?
In this domain.
Oh.
In that domain. You got to watch what the question says. If it just said this, you and I would have to do some K thing. Okay? So now, why don't y'all try this one? 4 sine x minus 2 equals 0. And we're going from negative 180 to positive 180. So your answer in degrees. Work it by yourself or with a friend. Those would be negative angles. That means you're going backwards on your sine wave. Negative 180, you would have negative angles. Going out to positive 180, you would have positive angles. There's some positive 1/2s back here. There's positive 1/2s coming and going. Sine's positive in the, oh, there's not any. There's none down there because I'm only looking this far back. Okay, raise your hand if you think you got the answers. All right, Bella?
Negative 30, 30, 150, and negative 150.
Do we agree? Okay, that's a work in progress. Isabel?
I don't think at negative 30 and negative 150 that sign it would be positive.
So this? 30 and 150? Okay, what was tricky about that one that I saw Isabel starting to realize is I do want you to go back this way. Like you're going to look down here at your 30-degree angles, but what is sine down there? Negative. So, but if I swing up to positive 180, do you see that Bella gets 2 answers up there? So the only answers are 30 and 150 to this particular problem. Here's a picture of it. This is out to pi or 180. This is back to pi or negative 180. And so do you see you've really got to have your thinking cap on to work these problems, okay? All right, now let me do another example. So this is where we're headed. Tangent squared theta minus 3 tan theta minus 4 equals 0. We're going to work this one together in interest of time. Okay? If this was not equal to 0, I would want to get it equal to 0 because do you see I'm going to have to factor this? Please don't write this down, okay? I'm going to show you. I'm not going to work it the way I'm about to show you. But soon I will introduce something called use substitution. Some books teach you to do this. Let u be the ugly part of your graph, whatever it is, equation. And then that would become u squared minus 3u minus 4. And you see it's like I just put glasses on your head and you see you've got to factor. Sure, you can factor for u, but in the end, what are you going to have to put back in? Okay? You can do that if it helps. You'll do that in other situations with me later in the year. I can just factor this, though. Once I get it equal to 0, factor the front, tangent times tangent, factor the back, 4 and 1. Look at your smiles. You can get a 3. This one needs to be negative, and this one needs to be positive. So this one's going to give me tangent theta minus 4 equals 0. Tangent theta equals 4. This one's going to give me tangent theta equals negative 1. Are y'all okay with that? I don't know this one. I'm going to have to use my calculator, right? For this one, and there are some, sine couldn't be 4, but tangent can be, okay? I could do this one without my calculator, but if I'm going to have my calculator, I might do it anyway. But let's answer the ones on this one from 0 to 360 before we go. We've got to be careful. The period of tangent is 180. Okay, my tangent graph looks like this up to 90. And then it looks like this up to 270. And then I still have some more like this up to 360. Okay? And so how many times should tangent equal negative 1 during that time? From 0 to 360? Twice. Okay? So the first time I think of tangent being negative 1, if I'm going from 0 to 360, is 135. And the next one I think of is in the fourth quadrant, 315. So in reality, if you didn't think about the graph, it's a little bit easier if you just go from 0 to 360. Okay? Tangent's negative here and here. And I would then have to, hey, listen up before you pack up, because I've still got a minute. I'm going to have to go arc tan 4. It'll give me some angle that I don't even want. Please listen with my last 30 seconds. I'm not getting anybody to do it right now because we're in a hurry. But if I push inverse tan of 4, 4, it will give me one that I want. It'll go in the first quadrant and give me that one. Can I use that as a reference angle to get the one in the third quadrant?
Yeah.
What I was going to say is if it said tangent equals negative 4, it's going to look down and give me a negative angle, which I don't even want. I'm trying to go into the positive. So you'll take it with a little bit of gratitude, thanks for the heads up, and you'll use it as a reference angle. Okay?
Thank you.
I'll put different bits of homework in a minute. So watch for that. Bye. Happy Thanksgiving.
Thank you.